Find a 5-digit number for which the ratio of the number to the sum of its digits is maximum, and for the second part it is minimum. That is, you have to find two numbers. If you have not tried this question yet, you can pause the video for more time. You are watching Brain Exploders, the world where brain starts working. So here is the solution for the first part. This is the number over sum of its digits. First we will analyze this first digit in the circle. If we increase this digit, the value of this digit, then the value of ratio may either increase or decrease, and sometimes it may depend on other digits also. Now here we can check it by simple logics also, but we will show you with calculations. So let us suppose that our number is A, B, C, D, E, where A, B, C and D etc. are single digits, and its expanded form is A times 10,000 plus B times 1000 plus C times 100 plus D times 10 plus E. Here we have to maximize number over sum of its digits. So we have to maximize this right hand side written over here. Now if we increase A by 1, then the new ratio will be A plus 1 10,000 plus B times 1000 plus C times 100 plus D times 10 plus E over A plus 1 plus B plus C plus D plus E. Now we will check which of these is greater. Okay, so let us suppose that on multiplying n over m in our previous ratio, we get the new one. Here n is multiplied in numerator and m is multiplied in denominator. We will find the value of n and m, and if we got n greater than m, then it will be clear that n over m is greater than 1, and hence the ratio increases on increasing a. Now here we get n is equal to 1 over a plus b by 10 plus c by 100 plus d by 1000 plus e over 10,000 plus 1. Similarly, we will find m, and we get m is equal to 1 over a plus b plus c plus d plus e plus 1. Now we know that a, b, c, d and e are single digit numbers, so it is clear that a plus b plus c plus d plus e is greater than a plus b by 10 plus c by 100 plus d by 1000 plus e by 10,000. And even if these are not a single digit number, even then here LHS is less than RHS. So we get n is greater than m. Hence, for this first digit, ratio increases on increasing this digit. Hence, a should be taken as much as possible, and the largest one digit number is 9. So we will fill 9 in this first block. Now let's move to our second digit, and if we check it by logic or even by the calculations, then we will get that the ratio decreases on increasing this number. Since we have to maximize the ratio, hence we have to decrease this number. So we will fill as less as possible here, but we cannot repeat the numbers, so we cannot fill 0 in all the places. So this number should be as less as possible, and also the number should be in descending order because it will help in giving larger place values. So our number is 93,210. Now let's do the second part. Here also we will check it for the first digit, that whether ratio increases or decreases, or it depends on other digits. So here we get that on increasing the ratio increases as we have earlier calculated. So since this time we have to minimize the ratio, so we will fill the minimum number here, that is we will fill 1 here. Now we will check it for second digit, but this time we will get something different. Here you will see that it will depend on other digits, that is it will depend whether C, D and E are less or greater than something. So we will check it later, and all these left digits will be clearly give that this should be as much as possible. Now we will analyze the second digit. So again with the same concept, we will suppose that our number is ABCDE. Its expanded form is as before, but this time we will take B plus 1 in place of A plus 1. Instead of A plus 1 we will take B plus 1 because we have to increase the second digit. Again we will check which of these is greater, and this time n is equal to 1 over 10 times A plus B plus C by 10 plus D by 100 plus E by 1000 plus 1, and m is equal to 1 over A plus B plus C plus D plus E plus 1. Here we have to check which of these is greater, or if we can reduce it a little, we can put A is equal to 1 because we have already calculated that A is 1 here and B is cancelled from both sides. So we have to check that 10 plus C by 10 plus D by 100 plus E by 1000 is greater or less than 1 plus C plus D plus E. Here it depends on C, D and E, but we know that we have to maximize the C, D and E. We have to take the values for C, D and E as much as possible, that is we will take 7, 8 and 9 here. So on putting 7, 8 and 9 in place of C, D and E, we will get that right hand side is greater here. So we get n is greater than m, and hence we have to fill the minimum number in this second place, because on increasing this number ratio increases, but we have to decrease the ratio. So with these conditions we will get 10,789 as a solution. Hence for a 5-digit number, number over sum of its digits has a maximum value of 6,214 and a minimum value of 431.56, and this is our solution. Let's move to our another question. In the following figure, find the length of the longest smooth path connecting opposite corners of a square which obeys the following conditions. Path may not touch or intersect itself at any point, and path should follow the lines in the figure. Try this question and comment as the solution, and if you have any question like this, send us on the Gmail given in the description box. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.